Okay, we are going to now use some skills that we've used in the past and apply it to this slightly new concept of solving a system of linear inequalities. So we're going to do this with graphing only, and we're going to graph these things just like we graphed our linear inequalities a few lessons ago. The only difference is now we are going to try to find out where the shared shaded region is. All right. And so we're going to look at two examples here that deal with when you get one specific region that is shaded. And so we'll look at two versions of it. All right. So the first version we're going to look at is the version that everybody likes, me included, and that is when they give you both equations in slope-intercept form, because you know how we like to rewrite things in slope-intercept form. But if they're already in that form, then it's pretty much just plug and go. So what we'll do next is we'll look at these and we'll determine what's our slope and what's our y-intercept for each of them. We'll graph these. So my slope for this first one is this number that's right here in front of the x. So my slope is -2. My slope for this bottom one is 3, right? And then if we look at y-intercept, we've got -5 for this one, right? And then for this one, you've got +4. So for this top equation, let's start with -5, right? You always start with your y-intercept, and then we'll apply our slope. So let's go with black here. So we're gonna go down here. We're gonna go, all right, put that guy there, and that's my y-intercept, and then my slope is -2, which means that it's -2/1 or down 2, right? So down 2 and then over 1 to the right. So we're going to go down 2, so we're going to go 1, 2, then we're going to go over to the right, and now we are going to put a line, and we'll try and approximate that as close as we can. These can get a little squirrely sometimes, so we'll get it close. You'll see that it's already set up for a dashed line here, and we kind of want that, and the reason we want that is because this does not have a line under it, so this is going to be the dashed line for this boundary, if you remember that, right? If it was less than or equal to, then it would be a solid line, but when they're open, it's a dashed line. Right? And if you got to make a note to yourself, like something like this, say dashed, sorry, not open, right? And then when it's like that, then it's solid, right? So that's this line. And now really quickly before we go on to the next line, it says it's less than this. So when we shade it, you want to shade below the line, right? So any point that is below this line is going to be part of the solution set for this particular problem. So we're going to just put in some little shading there. Okay, like that. We'll erase some of that later. And now we have y is greater than 3x plus 4, so let's plot 4, all right, which puts me up here. Okay, and then we have my slope of 3, so it's up 3, so 1, 2, 3, and then over 1. So you have a point right here. And then this is also dashed, right? And so when I draw my shape and my line, I'm going to change the color to green. We'll go with that. And then I think it's already on dashed, and it is, so we're good. And so we're going to do a dashed line that comes down and go like that. This is my second line. We'll put on some arrows. And then for the shading for this one, this says y is greater than 3x plus 4. So that means that it's everything above this line, right? So we're going to go here, 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 here. And so now what you want is you want to see where do these shaded regions overlap? Well, if this whole thing's here and this whole thing's here, the only area they overlap is this V here to the left, right? And so that's what you're going to shade. You're going to go shade up to that. And then when we get to your vertex there, and then we're going to follow the shape of this, like this. And that is how these are shaded. All right, and so both dashed because they're not or equal to, right? They're just less than or greater than. And then the shading is just kind of a recap of what we did when we did lesson 1.5 day 2. All right, so now this second one we're doing here, right? The hopefully you recognize that, hey, I can work with this one, right? You got your slope here and you got your y-intercept here. So my y-intercept is -3. Let's go down a little bit here. And my slope is +2. So that means up 2 over 1. So we're going to go 2 and then 1. And then this one is also a dashed line. So we'll go with the purple to start. And then we'll go, oh, I guess it liked green, so we'll keep it green. That's fine. I wonder if I do that, if it does anything. No, it doesn't. All right, so let's put our arrows on the end of it. All right, a little sloppy. I should have made it a little bigger, but the computer makes this not so easy. Now for this second equation, the top equation, what we want to do is we want to have this written so it looks like this. So it's in slope-intercept form. So we are going to do that. So we got -2x minus y is less than 5. So always start by trying to get y by itself. So let's move -2x over to the other side by adding it. All right, get -y is less than +2x plus 5. And then the last step is to get rid of this negative sign with your y. And keep in mind that when you multiply by a negative or divide by a negative with inequalities, you are always putting yourself in a situation where you have to flip the sign. So my sign's going to flip, right? Because that's a -1 that we're multiplying by. And then this becomes +y is greater than -2x minus 5. All right, because essentially you're reversing it, right? So you got to make sure you reverse the sign as well. So y is greater than -2x minus 5. Let's find -5. That's my y-intercept. Remember, that's always that number right there. That's your y-intercept. And then this number is my slope, right? And that's your -2 over 1. So I'm going to go from this -5, I'm going to go down to an over 1. You probably recognize this from the last question. It's kind of weird how they both have the same thing, right? So switch my line over, and now we're going to do, I'm going to move this up a little so I can get a little more of this. So we're going to do another dashed line that goes through here like this. Okay, put your arrows on. Red arrows, purple arrows, no thank you. There we go. All right, so last thing we got to do is just figure out how to shade this, all right? So this one right here, this y is greater than 2x minus 3, that's this one right here. It's above it, right? It's greater than, so you shade the top part of the line, right? So we're shading this area. And then this one, you have y is greater than -2x minus 5. Remember, you got to look at the slope-intercept form to do this, right? Because that trick only works with that. So if it's greater than this, that means that on the purple line that we're shading this side. And so if that's what's happening, then that means that this ice cream cone shape right in here is our shared region. That's the region that satisfies both of the inequalities, and that's why we shade just that part, right? So hopefully that makes some sense to you guys. And yeah, and that's how these work. Pretty much the hardest thing with these is the rewriting, and then just remembering that when you're shading, you have to shade the shared area. All right, shade the shared area. All right, good luck with these, and we'll see you in the next video.